Hello everyone and welcome you for the previous class. We are discussing the chapter System of Particles and Rotational Motion. So till now we came to know about the center of mass, then we came to know about the moment of inertia concept. Also we have derived in the last class the relation between the moment of inertia and the kinetic energy. So hope all the things are known to you. So today I'll be teaching you the theorems of the rotational motion. So in case of theorems, we have two main theorems. One is theorem of parallel axis, another one is theorem of perpendicular axis. So one by one I will discuss these two. So hope try to understand the concept, because next class when I will do the live class, then we will discuss the application of these two in some situations or cases, I can say. So let's start with the first theorem, that is theorem of parallel axis. So what does this statement? The statement I have already written on the board. It is given that according to the parallel axis theorem, it states that the moment of inertia about an axis is equal to the moment of inertia about the parallel axis passing through the center of mass plus the product of the mass and the square of the distance between them. Since the theorems are written exactly what is given in the book, so I have written it in the book. Now, if I want to explain what is the meaning of the statement, means let us give an example. Suppose this is a body. This is an axis of rotation. Suppose I say this is AB, axis of rotation. The moment of inertia about an axis, so about axis AB, is equal to what? Moment of inertia about a parallel axis. We have to draw a parallel axis that will pass to the center of mass. Suppose this is the center of mass. So this is passing to the center of mass. Suppose I have written x, y. So it will be equal to what? The moment of inertia about this axis. Suppose I have written this as I naught. This one is my I. Then according to the theorem, I will be equals to I naught. Then it is given plus the product of the mass plus the product of the mass and the square of the distance between them. Suppose this distance I have written d, it will be md square. So this is the meaning of the statement. Hope it is clear. Means we have to find the moment of inertia about an axis and it states that that will be equal to the moment of inertia about an axis which is parallel and passing through the center of mass. Also plus we have to make the give the product of mass of the body and the square of the distance between the two. So that is my statement of the first theorem, that is the theorem of parallel axis. Now how to prove it? Suppose I say again I am drawing, this is the body, this is an axis AB. I assume that moment of inertia is I about this axis. This is the center of mass, I will write CM here, and this is the parallel axis which is passing through it. And let us assume this distance to be, I have written D, let us write as H. And here is the particle of mass M at a point P. Here I have considered a particle of mass M at a point. Hope it is okay. Now see, if I say this distance is x, this distance is x, I am going to derive it. So this one I have written x, y. Let me mark it as I. Now let us assume. If I ask you, so what about AB? And if I ask you what is the moment of inertia about P, of mass M about xy, what will be your answer? If I ask, you will write moment of inertia of particle at P is equal to mx squared. It's okay, this is the moment of inertia. Now if instead I asked you what is the moment of inertia of the body, entire body, you will say that ma'am, it will be sum over mx square. Is it okay? Yes, sum over mx square. So this is the moment of inertia about body. Now if instead I have asked you what is the moment of inertia of the particle about AB, means about this particular axis, then you will tell me that ma'am it is m, it is x plus h whole square. Hope it is okay? Yes, this one is my moment of inertia of the particle about the axis AB. Now if instead I said moment of inertia of the body about AB, you will tell me the answer. It will be equals to, suppose I have written I, because I said this one I consider it to be I. So I will be equals to sum over m x plus h whole square. Isn't it? Because mass I have to do it. Now the next part is, if I do the multiplication, that is m, the first term will be x square plus sum over m will be there, then twice of x h will be there, plus then sum over m, then h square will be there. Okay, got it? So this is my answer. Now after this, if I talk about this part, it is sum over m x square, then this value is nothing but this one. So I can write this as I is equals to I naught plus next part is sum over m h square plus the next term m. So 2 is constant, I can take out sum over m x h. I got this relation for moment of inertia. Yes or no? Yes, I got this relation for moment of inertia. Now, if I talk about this part is 0. So I will get the relation I naught sum over m h square. So that is my first topic, that is I have proved the parallel axis theorem. So hope you have understood the proof of the parallel axis theorem. So can I will move now to the perpendicular axis theorem. So we will use this in next classes. Like suppose I say, let me give an example so it will become clear to you. If it is a regular body, where is the center of mass? The center of the body is the center of mass. Now if it is a spherical shell or a disk, if I say this is the center, if I am drawing a 3-dimension, let me draw, it's okay, no problem. Let me draw a 3-dimension on this way. So this is the disk and this is an axis. Can I say it is passing through the center? Yes. And if I want to find a moment of inertia about the axis which is tangent, then I will use the parallel axis theorem. Okay, so let's move to the next topic, that is the perpendicular axis theorem. Now the second theorem, that is the theorem of perpendicular axis. So according to theorem of perpendicular axis, the moment of inertia of a body about an axis perpendicular to its plane will be equal to the sum of the moment of inertia of two mutually perpendicular axes in its own plane and intersecting at a point where the perpendicular axis meets. What does this mean? Again I will take an irregular body so that it becomes easier for you. This is an irregular body and this is the axis. This is an axis, about an axis perpendicular to its plane. So I consider this body to be a body and this is the plane of the body, and here I have drawn an axis, then I consider this to be the axis, perpendicular axis. Then on that perpendicular axis at this particular point, can we draw two mutually perpendicular axes? Yes, I can draw. One will be along this side, another will be coming up. Since we are talking about the x, y and z axis. So this is my x, this is my y, this is my z axis. So according to the perpendicular axis theorem, x, I, y will be equal to ix plus iz. That is the meaning of the statement. So the theorem is not so hard, but the thing is that When we write the statement write accordingly as given in the book. You cannot use your own statement. So that is my perpendicular axis theorem. Let me prove it how the perpendicular axis theorem is, means how we got it, because we have learned in maths also if a theorem is there, then we must have it proved. So this is the axis of rotation. Let us assume this axis to be I, Y. Done? Okay. And this is my X and this is my Z. O is the origin of the coordinate system. Let me draw O here. Suppose I say this is a particle P of mass M. This is a particle of mass P, mass M at a point P. Now, from the origin, the distance is I have assumed to be R. From the origin, distance is R. So when it is rotating in this direction. It's okay, it is rotating. So what is the moment of inertia of this particle? Moment of inertia of this particle at P, if I say, it will be equals to mr square. Yes, the mr square will be the answer. Now, but if I talk about this particular figure, coordinate system, then if I draw a perpendicular like this, and if I join a perpendicular like this distance from here to here, if I write it as A, can I write this as X? Because this is X. And from here to here, if I talk about this is the Z axis, so this will be Z. So this, if this is Z, then I can suppose this is my B. So this one will also be my Z. So it's a right angle triangle we will get. So we can write from the figure R square is equals to what I can write, X square plus Z square. If I multiply by M, I can write mr square is equals to mx square plus mz square. If I talk about the entire body, I can write sum over mr square is equals to sum over mx square plus sum over mz square. What is mr square? Mr square, if I have taken this r is the distance from the y-axis. So this is the moment of inertia about y-axis, which is equals to, if I talk about x, then it is the moment of inertia about x-axis. Then the other one will be about z-axis. So this is the proof of the theorem of perpendicular axis. Hope the two theorems are clear to you. One gives parallel axis, means we have to consider two parallel axes, one through the center of mass, other through normal axis. And if it is a perpendicular axis theorem, then what happened? We have to consider three mutually perpendicular axes. Think of the x, y, z axis. So hope you have understood the concept. If you have any doubt, you can talk with me in the next class. So for tomorrow's class, we will have the application of these two theorems. Thank you. That's all for today's class. Have a nice day ahead.